their scope of works. So it's not a scenario where we could have all the teams there for 4 weeks because we'll just run out of beds. So we have to schedule the teams and also how the equipment will arrive. So we've got 3 schedules we've got to work with. We've got one being the timeline as to what client wants and when we need to hand over each structure. And then we've got the timeline of the guys that are doing the structures. So the team that are building the structures have got a certain timeline that they working towards given the size of their team on the island. So they have X amount of people, they can build X amount of units, and they can complete X, Y, and Z in the following timeline. We then have the third leg, which is the logistics side of it, where we need to work with the suppliers in South Africa, get the timeline correct in terms of when we can take delivery, X works, then allow for the correct time to travel across border and into the middle of Mozambique, then do a cross transfer over onto a vessel, onto a boat, which then transfers the equipment to the island, and then we have an offloading process on the island. So these different schedules all need to basically, they're intertwined.
They all need to line up and make sure that they're at the same time, obviously.
Exactly, and at the front of all of this is the cost implication of all of it. So that's where my concern comes from. As you can understand, we with the power generation side, we've basically confirmed the your current automation costing, and you guys are supplying the equipment for us. It just makes sense that we use a supplier installer that's familiar with your systems. And in this case, I believe it's an installer that has actually worked in these conditions before, which obviously
they're busy building an island just north of you guys. So
yeah. So that is massively beneficial in terms of expectation and timelines and so forth. But with the PV install and the inverters and linking that side, the DC side, into the LV room or the main connection room, control room, there's then the AC side of it, which is currently being designed by our electrical engineer, who is designing the whole system based on the specification given to him on site locations, distances involved, cable routing, demand, total power consumption, etc., etc. This information has, obviously been supplied through to him. He's designed the layout of the AC, including the cables, kiosks, up to the DBs, and that's all being written into spec, and that spec has to be countersigned by the Mozambique counterpart, because we have to run through a Mozambican entity for our building permit and to get the sign-off on it. So that's all happening in the background. Now, where we have got room to maneuver still is who's actually going to do that AC install on site. So the procurement is currently underway, and has a lot of time has been invested into making sure that the procurement is done correctly. But getting all the kits to the island, transferring it to the site, and then the actual putting it in and getting it all sort of installed, and then obviously the commissioning of it. So where we then have somebody that actually can commission the DC, the AC, the generator connection, the communication between all of these systems so that it functions in the intended operation and what we designed the system. So this is where I wanted to know whether or not, given that we're going to have a team on site that is capable, that are most likely going to spend some time waiting on curing or waiting on X and Y, whether or not we can incorporate the AC process into that period of time that they're going to be spending on the island.
How much AC are we talking about? Is it just the connection from the inverters to the main distribution board, or is it the AC from the main distribution boards and the reticulation of the island as well?
It would include the reticulation. The reticulation at this point, our services, we supply to within 2 meters of all structures, and the connection point then from there is made by the electrician and the engineer on the structure company side. So there's a clear division in terms of where the COC from the structure stops and where the COC from a reticulation perspective hands over. Hence why the kiosk design. So we've got the main LV room. We have a main kiosk. So there's a main line that runs between these two. Then from your main kiosk, you've got smaller mains that run to your sub kiosks or your mini kiosks. And from those mini kiosks, you run to your different DBs, the distribution boards inside each of these structures.
I think if you can give me, let's say, a layout of the island and just highlight the sections of the reticulation that we need to complete, then I would be able to say, okay, yes, it's possible, or no, it's not possible. Because without having actual distances and layouts, it's very difficult to say yes or no.
Absolutely. Look, we can most definitely do that. Leon, I'm speaking out of turn here, but I think you would probably be best to summarize what that would entail. And then the just so that you know, we've got machinery and site managers and labor on site. So when it comes to trenching and digging and that kind of stuff, this will all be done and by a team that's working off a plan. Leon will specify the depth that each sort of run needs to be at. So, and this has all been marked out, GPS, everything. So when we're talking about your guys doing the AC side, I'm not expecting your guys to be doing any trenching or anything like that. As a matter of fact, our guys will also be able to, the labor and my site manager would be able to move the cables into place, lay them down, make sure.
Exactly. We just have to do the final connections, basically.
Final connections, making sure
that,
that they're running where they intended to be, off spec, off plan. The kiosks will be made up already and approved and signed off. The DBs will be made up, signed off and approved. So it's literally working off plan, making the connections, ensuring that the spec that's been written has been followed. And then once the commissioning has been done, to issue a COC on that installation. Do you know what I mean? Which will then be signed by the local Mozambican electrical engineer.
Yeah, so Ben, sorry for the interruption. So basically what we can do is that, the kiosks and stuff are already labeled and are designed for each certain breaker. So the cable trenching and the cable laying can actually be done by our local teams and site managers, so to say. Where you would come to play is just to do the final check, so polarity check and insulation check prior to the termination. So it will be the termination, and that's your cold commissioning done, and it's terminated. It's done. When we switch
we'll bring a mega whip just to mega the cable to make sure that the cables are
you can do a mega test. And I mean, over that distance, insulation testing will be fine. I mean, you'll run it for 2 minutes or so to say.
Exactly.
So, and then we can, just check all the phases for the three-phase cabling, and just check if the insulation is similarity. So, in terms of the termination, that will be terminating at the different kiosks where you will see now, in terms of where these kiosks will be located. Our site plan indicates it quite clearly. And then once the PV side is done, I mean, your PV installation will be all up until the distribution box in the same LV room, because the inverter and the batteries are all in a LV room that has been pre-designed, and we've done the layout, and we've got AutoCAD and plans drawings exactly for the layout of the inverter room. So this has all been pre-planned, and the trunking will be pre-planned for the inverter room as well. So this is actually made easier. In terms of the final commissioning, that's your hot commissioning, with only just to see if everything's still working. When you switch on, you'll be switching on step by step and monitoring or soaking a cable, so to say. Obviously, the elephant in the room is obviously your timeline has been given, but if we can cooperate just into that, and apologies, and then myself and Paul are working on the structure methodology, because like I told you, Anthony, Slater is over designing, and nowhere in the world are structures installed like that, even with their own structures. So they need to come to the party and give us clear calculations what they want to achieve, and we will achieve it, but we will not put 80 tons of concrete into the field. So that's even in a 50 megawatt plant, you don't even put 80 tons of concrete into a field. And these are embedded at 1.2 meters deep. Our piles here are at 1.5 meters deep.
Yeah, I think that.
No, I agree with you. We like we discussed earlier, I think they're being a bit German in their methodology of over design. Let's times it by 2 and see. Oh, it's not strong enough. Let's times it by 2.
There's safety factor. Yeah, that's the European code. But listen, but in all honesty, you've got no load bearing on the structures until the modules come into play. The wind load is at the modules. What is the only thing holding in the modules is the actual clamps. There are 4 clamps which are holding a module on 2 mils of frame. So that's where the modules will break. So if they're designing something at 56 meters per second in gust wind, that is 203 kilometers an hour gust wind. That's level 4 hurricane, let's so to say. Okay? Fine by me, but they cannot design.
Let's be honest, if that does happen, the insurance is going to pay out anyway, because I mean,
it's a force majeure. It's a force majeure, but the structures need to be designed in order to hold, a constant wind of 35 meters per second. And what they are seeing is that it's just sand. Myself and Ben, we actually do have photographs of them digging into the soil. Ben, if you can just send that to me now, I'll send it to Paul. He's on a call with Schletter as we speak to design these structures. Because if we do have a possibility, Anthony, of creating a machine that can direct embed it, meaning a ramming machine, there is a possibility that if the front rows or the side of the rows need some concrete ballast, all fair enough, but the entire structure will not need ballast.
Look, to be in all honesty, most of the time when we do ramming, we don't need any concrete ballast, right? Provided that
but it's in firmer soil.
Firmer soil, So I mean, I don't know at what depth you hit a firmer soil on this island.
It's approximately, and Ben, correct me if I'm wrong, it's approximately like 300 mils of really sandy sand, but then it gets really dense, and the density is quite consistent as deep as we go. Ben, how deep did we go on that DP test that you guys did?
We went up to I think it was 2.5 meters. And the first 500 mil to maybe 600 was relatively sort of like quick in terms of how much each blow, because it was an 8 kilogram weight that we did the blows with. But the minute when you get to 600, all the way through to 2 meters, each blow was like consistent all over the island between 8 and 9 mils per blow. And I mean, we are putting our units that are 9 by 5 meter structures are floating on a non-wet concrete footing system that is purely sitting in that soil. And it was signed off by the engineer like that. He was like, this soil is some of the better soil that we've seen in terms of consistency. Now, I understand our footing system is different because we work on an angled approach. So the friction is obviously different as to working on a straight.
Yeah.
But that said, if we are able to work on a compromised install where we go, yes, fine, fair enough, this is the DPT test, this is the photograph, we're saying let's concrete maybe every 5 sort of legs, or you know what I mean, let's do some of them but not every single one, because like Leon says, we don't want to be carting 80 tons worth of concrete to the island. It's just impractical.
Look, I must just find that pictures of that site we did in the Kong in the DRC, because that was very sandy soil as well, where we also rammed for 2 megawatts worth of PV, and that's still standing.
How deep did we ram? How deep?
Robben Island, this was 1.2 meters or 1.5 meters generally with embedded structures.
Yeah.
Robben Island is sand anchors.
Yeah. Through to that as well.
Yeah, it's sand anchors, not even concrete there. It's only nearly 1 megawatt. But I mean, we do all the calculations, and I've never heard of a ballast of one cube per leg. That's just not possible.
I mean, we didn't even do that for the Kruger National Park jobs. I mean, we laid a 3 meter by 500, 3 meter by 500 by 500 for 2 legs. It was a strip foundation that we laid for the Kruger National Park.
Yeah.
And I mean, and that one, it was even worse because at the Kruger National Park, we stuck the containers underneath the panel. So the panel was actually sitting 2.5 meters in the air.
Look, I think, this is something that Paul is obviously discussing with Slater in parallel to this meeting. So we need to find common ground, but we need the solution. Obviously, I'm also not going to wait 7 days for concrete to cure. By the 3rd day, concrete has matured and there's no load bearing. So to
Look,
say,
obviously, if we can do ramming, then what we can do is you can obviously ram the pylons in before we get there.
No, that will not work. I will need you guys to be there to see the set out points.
Look, I mean,
because you're building the structure.
It goes 2 ways in that also, Leon, that obviously, like I mentioned before, we've got a very limited team, and we've not allowed for teams to be ramming and doing that kind of setup prior. These guys have all been allocated to doing whatever jobs they've got. So I would assume, yes, I agree, we need to find middle ground. We need to find a solution that gets us to put the structure in that's going to be safe and signed off, but not a 7-day, 1 cube per leg kind of vibe. And we just need to see how do we get there.
I think what I'm going to do is I'm going to chat to Slater. I'm going to find out if we can ram, and if we ram at, I'm just going to find out if we ram, let's say at 1.5, or even if we ram down to 1.8 meters, right? Based on previous experience from them in sandy soil, is the 1.8 meters good enough? I think what we'll do is we'll find out very quickly, because we'll find out very quickly whether it's going to stay in or not. I think once you ram the first 3 in at 1.8 meters, we'll find out very quickly if it can pull out or not.
Yeah. And I mean, I think that the structure design is currently that it's 500 mils off ground level. So if you want to go deeper and only make it 300 mils off ground level, that specification is only there for, that specification is only there for shading if grass will grow, that you don't have to cut grass continuously. But in that area where we're building, we won't have much grass growing that quickly. So if we want to go down to 300 mil above ground, then it should be fine as well. Then you can go deeper.
Yeah, just a stupid question here. I'm coming maybe from the blind side of not having all the information on site. the cost of a rammer to get the rammer on site, is that being calculated at all? And is it required for the size of the PV site?
I've looked at cost of rammers and they are insanely expensive, and hence why I'm trying to steer away from it as much as I can. Unfortunately, I don't think I'm qualified to answer the question as to what we need for a size plant installation like that.
Anthony, what is the size of the PV?
150 kilowatt.
150 kilowatt for a rammer.
Yeah, that's overkill.
I think we're going off kilt here.
Yeah.
My initial plan was to auger down to about 1.5 meters, and then put the pylon in, and then to fill that hole with concrete, like we did in the Northern Cape. Because obviously then you just put these the anchors into the uprights at the different angles.
I think I agree with that, Anthony. That's going to be the better way. Then we don't have to put so much concrete in. Concrete.
Yeah, and my plan was to take an auger of probably about either 300 or 400 mil diameter auger, and that's the whole size we were going to do.
Okay, but even an auger, the problem with an auger is that machinery doesn't work always so well. If they've got laborers on site and we don't have to go that deep, surely they can just dig the holes. We've got cheap labor on site.
Yeah, you can do that also if you've got cheap
That's
labor.
the most practical way of doing it, is utilizing the labor that we do have on site. Either that from the mainland. Sorry, the island, is it also as far off as Jack's Island?
It's basically just a little bit south of.
Is it the same size? So larger?
Same size as Najogo, if I'm not mistaken.
Najogo, which is quite small. Do you have laborers on site?
1.2 kilometers by 600 meters.
And the cheap laborers, do they come and go onto the site, or they're permanently there?
So we've got a rotation of about 10 guys that we schedule between the teams, hence why the scheduling is so important, because we have to schedule those same laborers to work in each sort of section.
My suggestion is, I think from our side, once again, my lack of knowledge of the project is I need to find out the time frame. My suggestion is that we do a project management time frame, that we do a Gantt chart. Yeah, so we start planning a Gantt chart amongst ourselves and say, right, this is a typical planning for the project. This is the typical time that we required, and then we start adding the stuff in, like the laborers or the being on site and so forth. And obviously getting the equipment to site, getting the people to site and so forth. I think that's going to be our plan number one. Obviously, how quick, how many people, what's the site, all that kind of stuff, that we just have some kind of a bigger picture than where we are at the moment.
Yeah, I just want to comment on that. So we're already running Gantt charts and everything, because you can imagine that PV is only yet a small part of the entire project. I'm not going to, no offense, but I'm not going to run another Gantt chart.
Can you share? No. Can you share that with us? Then what?
Well, I can't because it's part of, it's interwoven into my bigger chart in terms of truck deliveries, boats arrivals, all that kind of stuff. But what I can do is give you information in terms of when the intended travel is.
Yes.
For when we're thinking to travel the equipment, when the plant room will be ready and built. In other words, when can we receive the batteries and the inverters on the island? Because I don't want them standing. I want them to go straight into the room if I can. And then kind of like put a forward view and say, right, we would like to commission by that date.
Yes, okay.
So then maybe with that information, you can work out kind of like what you need to allow, where do you need to slot in. So, and then I can take yours as we develop it.
Yes.
And I can put it on my side and see how does that conflict.
Absolutely. Fully agree with that. I have no issue. I think the Gantt chart was more for ourselves, from our side, so that we get our ducks in a row. I think just because we're a little bit coming in from the dark side. And what is the island? Is it a hotel as well?
So look, what I need to do, and I haven't done this with you, so I'm gonna ask you to excuse me, but I'm gonna need to get you to sign an NDA with us, just because there is quite a lot of information that I would want to share with you and that I need to share with you, but a lot of it is IP that we unfortunately don't own, and we're under NDA. So if I can get that sent off to you, you can sign it, and then I can share with you the information. Don't, you know, I mean, I want to share it with you. It's just I've got to.
You have an NDA. You know, I fully agree. I have no issue with that. We sign NDAs all the time.
Yeah, so I can do that today. I can get that off to you. I don't know if I've got your direct email address.
I've got Anthony's.
Yeah, just send my stuff via what you've got there, then I'll be put into the loop with the different stuff.
Cool. Then I can do that for you. And then I mean, the gist of it is that we've procured the system from you guys already. We are currently procuring the kiosks. We are currently procuring the cabling and the DBs. There are a lot of moving parts within the setup, which I will try and make as clear as possible now when I start sharing the info with you, that doesn't make it confusing. So I'm going to try and send it in little bits where it's sections. And then I'll share with you the relevant Gantt chart information that's relevant to the installation for this. Just one thing that we haven't touched on, because we're running a hybrid system, in that we've got a generator with the inverter and the PV, and we're running a D-cell plant. There is 3 different DB boards being built by 3 different kind of entities, because they each take care of their own and communication modules that at some point need to be put together by one person, right? By somebody that understands all 3 of these ways of communicating. Now,
do you have that person? Because we've got a box called the Real Box, which we can use.
Yeah. So what we're doing for Jack's Island is we're taking all the Modbus or the CAN bus or 485 information from the different items that needs to be monitored, and we put it we
into one platform
on a single platform with a network. So you can either locally view it by just accessing the database. It's on a Pi, Raspberry Pi, or we can take that data and you can put it in the cloud. So you can monitor it anywhere in the world to see what's happening to these different items. So we've got a very, very good developer that's doing that, because we've got different machinery on the islands. We've got Victron equipment, we've got the ATES equipment, and so forth. And we wanted to see what's happening, for example, with the diesel versus the kiosks where they generate the PD and so forth. We just wanted a global view, so we started developing that system, and it's quite far developed. So we'll gladly get involved, but we just need to know the bigger picture of what do you have and what can it communicate. So if that information can be shared, we can run with that.
Yeah, I can. I mean, that info will definitely be shared with you. And we've got a specialist on the team that is a generator, PV sort of and master electrician specialist. So he understands the different communication modules that come with the generator, so either deep sea or CEM or CEA, whatever we end up using, and how that needs to communicate with the inverter and with automatic changeovers and starting procedures, all that kind of stuff. But it's not to say that we have to have him.
Yeah.
If you guys have got somebody in the team that is capable. 20,000 Rand just in a work permit, flights, and getting to the island. So
do me a favor. Can you just
Yeah.
repeat that for me? I'm not sure if it's just my side, but you disappeared there for 30 seconds.
It disappeared, yeah.
Okay, so what I'm saying is we've got this specialist that can do all of these things, right? That understands all the systems, and he can do the actual final connection and communication stuff. But what I'm saying is it's not necessary that we have to go with him. If you've got somebody that can equally give us that service that's in that team, then for me that's a better solution, because every person that I take to the island costs us about 70 grand just because of work visas, flights, and getting the person to the island.
Yeah.
So the fewer people I have, the better for us from a cost perspective, and also the less people involved, you know what I mean? It's always better. So if you've got 2 people doing the installation and it connects and it communicates and it gives us the end product, then fabulous. But because we weren't sure who was going to do the PV install, the generators coming from a supplier, we procured the PV system ourselves because of wanting to make sure that we get the right system. We needed somebody that can put all of these things together. Yeah. Hence why we've lined up the specialist to do that. But like I say, if you've got somebody...
I think the best thing is let's get the NDAs sorted, and then let's start feeding information, and let's start putting our side in and starting to get batteries. We'll gladly advise you where we have maybe something that's blockage that we don't understand, and we'll farm it out accordingly.
Okay. Yeah, look, I mean, I just thank you for that. I'm going to get onto that. Just last thing from me is that it's not your problem, it's my problem. But we are, as it is, the system that we ended up going with, the PV system, we're R1 million over budget. But we had no choice. We had to go ahead and carry on with the procurement. I just need to watch every single cent that we're spending on this and making sure that we are just making sure that we're making the right decision and the smartest decision.
No, for sure.
Always.
For sure.
Cool.
Great stuff.
Cool. I think we've lost Leon.
We have, yeah. Looks like it.
Okay. I'll bring
what I'll do is I'll send Leon the data sheet on the rail box as well, so you can have a look at it closer.
Yeah, please, if you can, all communication, just keep it via Leon, CC me in, because Leon ultimately is my engineer, and he's the one that just kind of makes sure that everything is... Yeah.
Okay.
Yeah, he's
perfect.
From which company is Leon? Is he from A Unit?
No, so A Unit is my business. We're the main contractor. We supply in the turnkey. Okay. But Leon is consulting for us. He's employed into us from FM Energy, which is his company. They do FM Energy. They do big plants. They do 20 megawatt kind of plants, into Africa and remote side.
No problem.
But his family. So that's why we've joined.
Yeah, no problem. I could see he's got some good.
No problem.
You could see he's speaking proper knowledge there.
Yeah. Lekker, guys. Thank you for your time. I appreciate it.
You're welcome.
Thanks, Rabbi.
Keep you tuned. Cheers, cheers, guys. Bye.
And I'll phone you just now.
Yeah, okay, cool.
Okay, bye.